Wanted to go over 10 here because I'm asked to calculate the derivative, well, rather the partial derivatives of an expression which is a quotient. So I'm going to take out the quotient rule. Remember that the derivative of one function over another is the derivative of the first times the second minus the first times the derivative of the second. Hey, by the way, that numerator right there is just like the product rule, right? Derivative of the first times the second minus the first times the derivative of the second. Except for now we've got a minus sign instead of a plus. If we were looking at the product rule, there would be a plus sign right there, and there'd be no denominator. Okay, so you know what? I'll end the video with a little clarification of what I just said. But at any rate, notice that I kept this ddx symbol. I think it's important to be able to do this. I kept that ddx symbol over here to remind myself of where I still need to calculate derivatives. Right? I said the derivative with respect to x of this quotient is the derivative with respect to x of the first of the numerator times the denominator minus the numerator times the derivative with respect to x of the denominator over the denominator squared. Okay, again, I think that's a really important thing to do because honestly, while this might look like a rather complicated function to you, once you get outside of the nice, comfortable confines of a math class into your other science classes where you will be using partial derivatives, I promise you, stuff will look a lot more complicated. And it will be harder to keep track of all of the symbols on the page when you take partial derivatives. I mean, you might have, instead of 2 variables, x and y, you might have 17. That's realistic. A whole large number of variables. Okay. So I calculate the derivative with respect to x. It is 1. And so in the numerator I have 1 times x squared plus y squared. Right there. And x times the derivative with respect to x of x squared plus y squared, well, that's just 2x plus 0. So I have 2x times x, or 2x squared. And then I have an x squared minus a 2x squared. I simplify that in the numerator, and the denominator stays the same. Okay. And then I say by the quotient rule. And similarly, the derivative with respect to y of this, well, this time actually I was thinking to myself, this is a constant over a constant plus y squared. So I could really think of just leaving that alone, and this is like a 1 over constant plus y squared, or constant plus y squared to the negative first power. Take the derivative, you get it 12 down to negative 1, and then you get the constant plus y squared to the second power. Chain rule, let's see, by the chain rule. Okay, so let me give you a couple of extras here. I told you I was going to go back to a more detailed description of what I was talking about at the beginning, the relationship between the quotient rule and the product rule. So let's take a look at this. F times G. Instead of times, I'll have divided by G. All right. To make sure that everybody knows that ddx is hitting both of these, I'll have that. This is very similar to the derivative with respect to x of f and x and y times g of xy. Of course, we denote times as just writing two things next to each other. You don't want to write a dot. Now that means the dot product. You don't want to mean a big x-like symbol. That either means x or the cross product. We don't have either of those in mind. Okay, so the product rule says df dx, evaluated x and y, times g. Now, I write the df dx this way so it's clear that the ddx is only acting here on the f. It is not meant to go over and hit the g. Plus the first times the second. The derivative of the second, rather, dg dx. Okay, so the similarity that I promised was, let's take a look at the numerator. Everybody knows that the denominator is g squared. I find that part particularly easy to remember, but the numerator I always forget. Is it low d high minus high d low, or high d low minus low d high? I can never remember what the dwarves are supposed to sing. So the way that I remember it is in analogy to this, derivative of the first times the second. I think the derivative of the first times the second minus, instead of plus, the first times the derivative of the second. See how that and that are the same? So if I drop the of x's and y's, this is df dx g plus f dg dx. Okay, hopefully you're seeing the analogy there.